Okay. We started a revision today. Okay. This is grade 11 physics revision. First question, talk about physical quantity can be classed as a vector or as a scalar. Which pair of quantities consists of two vectors? I think you know the answer. So the answer here, two vectors. Kinetic energy is a scalar. Force is vector. He said two vectors. So kinetic energy is a scalar but vector. Force is vector. So this is not clear. Okay. So which two of them are vectors? Part C, velocity and electric field strength. Now, if I change, or if the question is that two scalars, if they are two scalars, then you think of that. Which pair of quantities consists of two scalars? Now you have to think of this. Next question, question number 2. Okay. He said the sides of cube are measured with, okay, calipers. The measured length of each side is. Now, what do we need here? We need to get here, okay. Can you see? Okay. So let us we solve this question together. The sides, please stop talkative, please. Okay, or you can make mute. The sides of cube are measured with this. The measure of length of side is 30 plus or minus 0.1 millimeter. The measurements are used to calculate the volume of the cube. What is the percentage? Can you see here? What is the percentage uncertainty in the calculated value of the volume? Now, first, what is the percentage of a side? So the percentage of side equal the uncertainty divided by the length of the side multiplied by 100%. It becomes 1/3%. We know that the volume of the cube is L cubed, the side times side. We need the percentage uncertainty of the volume. Then the percentage of the volume equal the percentage of side plus percentage of side plus percentage of side. The percentage of one side is 1/3% plus 1/3% plus 1/3%. When you add them up, it becomes 1%. So the correct answer is C. Okay. Now, let us see the next one. Question number 3. The value for acceleration of free fall on Earth is given by which statement is correct? The correct is the first part here. So this is the correct one. This is more accurate. Okay. So it is accurate but not precise. Now, question number 4. Question number 4. Yeah, just I checked. So the answer of this part is A. Next question. Micrometer is used to measure the diameter of two cylinders. Here, the difference in diameter. In plus or minus, we add the uncertainty. So the difference is 0.02 plus 0.03 equal 0.05. Then the correct answer is D. If you have any question, you can raise your hand or you can ask me directly. Question number 5. Okay. Velocity vector is shown. What are the components of velocity vector in the north direction and east direction? We resolve the velocity. So by resolving this velocity, near to the side is cosine. So north, it becomes 75. Cosine the angle. What is the angle? It is 30. And away is sine. Then it is 75 sine 30 degrees. Now, in the north, here, so in the north will be 75 cosine 30. By using the calculator, it will be 75 square root of 3 over 2 equals approximately 64.95 meter per second. What about in direction of east? It is 75 sine 30. By using the calculator, it will be 37.5 K, not degrees, take care for the unit. It is 37.5 meter per second. Then the correct answer of this is part C. 64.95, approximately 65, and the other one is 30. Question number 6. Which statement about scalar and vector quantities are correct? What is the scalar quantities? Has magnitude but not direction. Question number 7. A piece of string 1 meter plus or minus 0.02 meter is cut out from a ball of string of length 100, means minus. Calculate the length of the remaining string and uncertain. So the remaining length, we say 100 minus 1 equals 99 meters. The sum of uncertainties, it is 0.002 plus 0.002 also equals 0.004. Then the length of remaining, or the remaining length, so the remaining length equals 99 meter, 99 plus or minus 0.004, and remember the unit, it's meter. Okay. Ready? Okay. Okay, next question. Question number 8. Distinguish between vector quantities and scalar quantity. So the answer here is that vector has magnitude and direction, while the scalar has only magnitude. Magnitude. Okay, now state, okay, the next question. Okay, he said, state whether each of the following is vector quantity or a scalar quantity. Temperature is a scalar. Acceleration, of course, it is vector. Electric resistance is a scalar. Next question. We said a force, calculate the component of the force acts horizontal. The same as we solved it before, we resolve 7.5 Newton. Remember, near to the side is cosine, so it is 70.5 cosine 40 degrees, and away or vertical, it is 7.5 sine 40 degrees. Then the answer of this question is that in horizontal, it is 7.5 cosine 40 degrees. The answer equals 5.75 Newton. Vertical, it is 7.5 sine 40 degrees. The answer is 4.82 Newton. Next question. Read the question and try to solve with me, please. Okay? Read the question and try to solve. Okay? We said a particle is moving in a straight line with uniform acceleration. Which graph represents the motion of the particle? Yes, question? Mister, can you explain slowly? It's okay, yeah. But this is a revision, and we need to finish in 2 hours. I try. Question number 10. A particle is moving in a straight line with uniform acceleration. Take care, he said, uniform acceleration. Uniform acceleration, it means constant acceleration. Constant acceleration. This is a velocity time graph. So also here, distance time graph. Let us discuss each one. Velocity time graph here, it means the velocity is constant. So the velocity here is constant. But we talk about acceleration. So this one, B is not correct. Yes, please do not, please. Okay, thank you for not. Could you stop to? Yes, here, disable. Yeah, please. So here, for the uniform acceleration, the correct answer is C. But now, if we change the word from uniform acceleration to uniform velocity, if we write here uniform velocity, what will be the answer? Think of that. If it's
B.
Uniform velocity, yeah, the velocity is constant, so the time go on. Yeah, B it will be the answer. Very good. Please do not use your pen, please. Okay? Somebody use the pen. Can you remove this, please, if it's possible? Who did that, please? Okay, guys, please remove this line, please, that unit. Please, anyone did that? Can you remove it, please? Thank you. Okay, please. Thank you. Now, question number 11, he said, the velocity of an object during the first 5 seconds of its motion is shown on the graph. What is the distance traveled by the object? The distance is the area under the graph. Then the answer of this part is that it is the area under the graph. So displacement equals the area under the graph. Now, he said on this time, it means the total area of the triangle. So it's a half multiply base multiply height. So it's a half multiply 5 multiply by 20. Then the answer, okay, becomes, okay, 50. But if he said not in this time, if he said in the first 2 seconds or in the first 3 seconds, so we need just the area in the first 3 seconds or 2 seconds or whatever, not all. So I advise you to read, please, the question, be careful. Then the area required in the first 2 seconds. So we have to draw a line like this. So now we find the value in 2 seconds here. Then we find this value. Okay, now I increase here to get this answer. So it is 0, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each, okay, 10 dashes equals 5. So 1 dash equals 5 divided by 10. It is, okay, 5 divided by 10. 5 divided by 10. It is 0.5. So each one is 0.5. Then this is, okay, 5.5, 6, 6.5, 7, 7.5, 8. So this point is 8. Then what will be the area? Half base times height. Then the area, okay, he said, what is the distance in the first 2 seconds or 3 seconds? Then just we find the area of this triangle. It's a half base, remember, half base times height. Okay, next question. Question number 12. Okay. He said the velocity of the car changes as shown. What is the acceleration? In velocity time graph, the acceleration equals the slope. Then we find the slope here. So the slope equals the vertical change, which is 80, over horizontal change. Okay, what is the acceleration? But take care. Here the velocity in what? In kilometer per hour. Then we write 80 multiply 5 over 18 divided by the horizontal change, which is 20. Then when we do that, we will get the answer 1.1. Okay? So the correct answer here is 1.1. Okay? Question number 13. Okay, question number 13. Let us read the question. He said, a football is dropped from the top of tall building. Which acceleration time graph best representation of motion of the football through the air? So take care here, said. So we have air resistance. So we have air resistance. Then the acceleration here decreases gradually. So the correct answer is C. But if we change this one and we said ignore air resistance, ignore air resistance. If we said that, ignore, okay, ignoring air resistance. Now think, what will be the answer if we said ignoring air resistance? If we ignore air resistance, the acceleration will be constant. Then the correct answer will be D. Because if there is no air resistance, so the acceleration is constant. Yes? Okay, Mr. When you come, 39. Okay, now let us, we go to the next question. Question number 14. A science museum. Now we can explain the difficult questions to go quickly. If you have any question, just send me a message or raise your hand. Question number 14, which formula we use it for number 14? We use S equals UT plus half GT squared. Then the answer becomes 1.3 for this. Then the correct answer is A. Question number 15, it said define the acceleration. So the acceleration is what? Is the rate of change of velocity. So this is the definition of acceleration. Now, question number 2. In that question, we have to write the givens. Let us do this. Here down. What are the givens of that question? A car is moving along a road at 8.0. It then speeds up. Then the first one is the initial velocity. So the initial velocity equals 8 meters per second. Speeds up, so the final velocity is 20 meters per second in 4 seconds, so the time is 4 seconds. So that are the givens. What is the acceleration? So the correct formula that we can use in that one, or the best formula, is V equals U plus 80. We do substitution. So by using the substitution, the acceleration equals 3 meters per second square. Yes? Question? Yes? Mister? How many velocity will come in the exam? I don't know. Okay? Yeah. Now, part C, if you said, if the car then decelerates at 4, how long? So now, how long that it take to stop? Then what are the givens in this part? Here, the initial velocity will be the final velocity at the beginning, 20 meters per second. He said to stop. Stop, it means that the final velocity equals 0. And he said deceleration. So A equals negative 4 meters per second squared. What do we need? We need the time. Then we use the formula V equals U plus 80. By using this formula, the time will be here. V is 0, initial velocity is 20, plus negative 4 multiply t. From this equation, t will be 5 seconds. Okay. Next question. Okay, question number 4. So next question number 16. It said the graph shows the motion of the car traveling along a straight road. What is the initial acceleration? Initial acceleration is the slope here, the slope of this part. So A equals the slope equals the vertical change over the horizontal change, will be 2.8 meters per second. The deceleration is that one. So it is negative here. So it is deceleration. It is the slope of the last part. So the deceleration, first we find the acceleration, will be negative. The vertical change, it's 14. Over the horizontal change, 15 to 25, 20 to 25, it's 10. Then it's over 10. Then it's negative 1.4. So the deceleration equals 1.4 meter per second square. How far does the car travel in the first 5 seconds? How far? It means the displacement is the area under the graph. So this equals the area under the graph. It is area of triangle. Then it will be half times base times height. Height here is 14. Then it becomes 35 meters. Now, how far does the car travel in total? We need the total area under the graph. So this equals the total area. The total area, it is area of trapezium. If we have trapezium like A and B, and then this is the height h, so the area equals half sum of parallel bases times height. So the total area equals half multiply. A, it's from 5 to 15, so it's 10. So this is A. And B is 25, so this is B. And the height is 14. Then we write here 10 plus 25 multiplied by 14. When we calculate this, it will be 245 meters. So this is how far does it, okay? Now, Now, next question. Question number, yes, question, yeah. Yes, question. What is your question, ma'am? Yeah. Yes, Abdullah, what's your question? Question. What's your Abdullah? What's your question, Abdullah? Okay. No? Thank you. Next question. Question number 17. They said the figure shows the variation of velocity v with time t for a small rocket. Said, assuming that the air resistance has negligible effect, without doing any calculation, describe the motion from t equals 0 to 25. So the rocket moves with constant acceleration from t equals 0 to 25, and then constant deceleration from 5 to 25. So we write here, constant acceleration, okay, from t equals 0 to 5 seconds. Then constant deceleration from 5 to 25 seconds. So this is the answer of this part. Calculate the height reached by the rocket. The height, it is the total area. Question? Yes. Abdullah, طيب, Abdullah, you need to get out, Abdullah? Okay, Abdullah. Yes, okay, Abdullah. خلاص. Okay, Abdullah. Where is Abdullah here? Okay, Abdullah, Captain Abdullah, you don't need the lesson, so thank you. Okay, yeah, Abdullah, where is Abdullah? Okay, I move it from this Abdullah here. Okay. Okay, Abdullah, you need to get out.
دخل الباسكود والاي دي لا.
Now, next question, please, here. Next question. Okay. Calculate the height. The height, it is the area under the graph. Area, it is half base times the height. Half base times the height. So half times the 25 multiplied by the height, which is 200. So the answer becomes 2,500 meters. So this is the answer of this part. Okay. Okay, Ahmed Al-Hidafi, are you ready, Ahmed? Okay. Just this is the time of revision, Ahmed. Okay. Yes. Question number 18. A car accelerates uniformly in a straight line from rest. From rest, it means that the initial velocity is 0. Then the given is that the initial velocity is 0. At rate 2.3 meters per second squared. So this is the acceleration. 2.3 meters per second squared. What is the speed of the car? So we need V. After it has traveled 55 meters. So this is S. Which formula you did? The formula is V squared equals U squared plus 2AS. Substitute. Then V squared equals 0 plus 2 multiply 2.3 multiply 55. The answer of this part is 253. Take the square root of 253. So the answer approximately 15.9 meters per second. How long does the car travel? So we need the time. So which formula we use it for the time? Depend on the given orders. So S equals UT plus half AT squared. So S is 55. Initial velocity is 0. Half multiply. The acceleration is 2.3 multiply T squared. From this, we can get T squared. So T squared equals 47.8. Take the square root. So T equals the square root of 47.8. The answer approximately 6.9 seconds. Next question, question number 19. A pebble is dropped down a wheel and hits the water 1.5 seconds. Then the time here is given. So the time is 1.5 seconds. He said dropped. Dropped, it means the initial velocity is 0. Determine the distance. So we need S. Okay. Of course, if something dropped down, the acceleration is 9.81 meter per second. Now we find the answer. Yes, there is a formula sheet. I will show you at the end of the lesson the formula sheet that will come in the exam tomorrow. Now, okay, so for this part here, okay, here we calculate from the formula. This is the formula. S equals ut plus half gt squared. Substitute. So S equals U equals 0 plus half multiply 9.81 multiply t squared, which is 1.5 squared. From this, the answer is 11.04 meters. Yes, question? Yes. Okay, up. Do you need to see this question? Okay. Okay. Now, next question. This about projectile. I said a golfer hits a ball so that it moves off with velocity. So we have here the initial velocity. So the initial velocity equals 26 meter per second at 30 degrees. So the angle is 30 degrees to the horizontal. Then we have this. This is the horizontal. And this is the projectile. So we have here U, and this angle is 30. Then we find Ux and Uy, the initial velocity, and, okay, in x-axis, and the vertical. So Ux equals U cosine theta, which is 26 cosine 30. And Uy is U sine theta, which is 26 sine 30. We can calculate the value of each. Now, we said the time that the ball in air. If we said just the time of maximum height, if we said the time of maximum height. So what we do for this? We talk about vertical motion. V equals U plus GT. And then we can get here the value of the time. So from this, the V equals 0 at maximum height. Vy at maximum height, Vy equals 0. And Uy, it is 26 cosine 30, will be 13. Check. To Uy, it's a 26 sine 30. It is 13. So Uy is 13. When it moves up, G is negative 9.81 multiplied T. So T equals 1.3 seconds. So the time of maximum height is T. So this is the time of maximum height. So the time of maximum height equals 1.3 seconds. What is the time in air? The time in air, we multiply this time by 2 because the time up equals the time down. So 2 multiply 1.3 becomes 2.7 seconds. The maximum height. Now, which formula for the maximum height we use it? We use the formula V squared equals U squared plus 2GS. Vy equals 0. Uy equals 13 squared plus 2 times negative 9.81 multiply s. Now we calculate s from this, the maximum height. 13 squared divided by open bracket 2 times 9.81. The answer is 8.6. Then the maximum height is 8.6. S equals 8.61 meter. So the maximum height equals 8.61 meter. The horizontal distance, in horizontal, the velocity is constant. Then just we use the formula for the horizontal, V equals S over T. Then the horizontal, it's V multiplied. What is V? It is the horizontal velocity. What is T? It is the time in air. So V is the horizontal velocity, which is 26 cosine 30, which is ux, and the T is the time in air. The time in air, it is double time of maximum height. Then S equals 26 cosine 30 multiply the time in air, we got it before, it was 2.7. Then 26 cosine 30 multiply 2.7. So the answer is 60.8. 60.8 meters. So this is the horizontal distance. So the horizontal distance equals 60.8 meters. Yes, question? Yes. Repeat. A, it's okay. Part A again, he said the time that wall in air. If I ask you the time, the time of maximum height only, then just find the time of maximum height. But the time in air, because the time up equals the time down. If the time up is 1.3 seconds, you will take the same time. But here, I used the value in the calculator. So for that, it's 2.7, not 2.6. That is the reason why it is not 2.6, because I used the value in the calculator. Okay? Okay? Now, next question. Question number 21. He said, a pencil is knocked horizontal off the edge of desk at 2.0. So this is the height, and this is the path of the pencil. Here we have horizontal distance, so ux equals 2 meters per second, but uy is 0 because it's horizontal, and the desk is 65 centimeters, it means 0.65 meters. How long? So we need the time to reach the floor, ignoring air resistance. Now we talk about vertical motion. We have u equals 0, uy of course, and we have s equals 0.65 meter, and we have g down, it's a positive 9.81 meter per second squared, and we need the time. Which formula you did? S equals ut plus half g t squared. From this formula, we can calculate the time. Just we do substitution. So S equals 0.65, U equals 0 plus half times 9.81 multiply t squared. From this, we can get t squared, and then we take the square root of the answer. It becomes 0.36 seconds, but I checked the answer. 0.65 divided by open bracket half 0.5 multiply 9.81, close the bracket equal. So the answer is, okay, 0.33, not 0.36. Why? Again, 0.65 divided by open bracket half multiply 9.81, close the bracket equal. So the answer here is, I remove it to north, 8, 2. It is 0.30. Oh, this is here S. Oh, this is t squared. Take a square root of the answer. So it is 0.367. That's now. What is the horizontal distance? The horizontal distance S equals V multiplied. What is V? It is the horizontal velocity. Horizontal velocity, which is ux equals 2. What is t? It is the time that we got it. We don't multiply by 2 because it is just one time. Then S equals 2 multiply 0.36. The answer is 0.73 meter. So the horizontal distance is that. So the horizontal distance equals 0.73 meter. Question? Yes? Okay. Now, next question, question number 22. We said a block of mass 0.6 kilogram is on a rough horizontal surface. The force 12 Newton is applied to the block and accelerates force. Which formula we used it here? Newton's second law. Resultant force equals ME. Resultant force, it means that the forward force in direction of acceleration minus the backward force. He said, what is the magnitude of the friction force? The friction force in that the friction force is F. Then the resultant force is the forward force 12 minus the friction force equals the mass, it is given 0.6, multiply the acceleration, which is 4. When we solve this, the friction force, it becomes 9.6 Newton. So the correct answer is D. Next question. Which of the following statements about the forces in Newton's third law is correct? Of course, the correct one here. Do not act alone. No, this is wrong. Act on the same body wrong. Are not equal in magnitude. Are the same type. But if we change the word here to wrong, if we said is wrong, what will be the answer? Think of that. Okay. Next question. Okay. Okay, please, Abdullah, if you need to get out, Abdullah, please, because you asked questions, but this question outside the topic. So please, if you wanted to leave now, please. Okay, thank you, Abdullah. Next question. Question number 24. He said, what is the acceleration? A box of mass 8 rests on horizontal rough surface. String attached to the box passes over a smooth pulley and supports 2 kilograms. When the box is released, a friction force is 6 Newton. So here we have the friction force. Okay, so the friction force here is in opposite to motion. So this is the friction force. He said it is 6 Newton. What is the acceleration? Here we form two equations. This is the weight, which is mg, 2 multiply 9.81. And this is the tension. This is the tension, the same. Then we need to calculate acceleration. For the 2 kilogram Newton, of course, we use this formula. The resultant force equals ma. So 2 times 9.81 minus the tension equals the mass multiply acceleration. This is equation number 1. Equation number 2, the tension minus 6 Newton equals ma. It's 18. This equation number 2. What do we say? We say add the two. When you add the two equations, cancel t with t, then 2 multiply 9.81 minus 6 equals 13.62. 2 plus 8 equals 10a. So from this, we can get the acceleration. The acceleration becomes 1.4. Next question. Okay, thank you. Next question, question number 25. Okay, let us repeat this question. Brake weighing 20 Newton. So the weight here is 20 Newton. This is the weight. Of course, the weight equals mg. So mg equals 20. Okay, now we need to calculate the mass. So the mass multiply 9.81 equals 20. Then we can get the mass. It's 20 divided by 9.81. So the answer here is 2.03. So this is the mass. What is the acceleration? Here he said, assuming that the acceleration of free fall g, no. In the exam, it is 9.8. We don't use 10. Here, this is the mass, the formula that we use, the resultant force equals ma. So the forward force is 10, minus the back force is 4, because it moves it down, the back force is 4, equals the m. M, it's a 2.03, multiply the acceleration. From this, we can get acceleration. So 10 minus 4 equals, divided by 2.03. So the answer here is 2.9, approximately is 7. Okay, next question. Okay, now next question number 36. Abdullah, لو تكلمت please Abdullah. Try to get out Abdullah please. لأنك الحقيقة معلش اسمح لي يعني. أنت بتسأل أسئلة outside. So sorry for you Abdullah. Where is Abdullah? Okay, Abdullah, because I said to you, please, Abdullah, do not. Where is Abdullah? Abdullah. Okay, I think Abdullah is A, is it? Okay, Abdullah is written by A, is it? Is A for anything else, Abdullah? Okay, yeah. Yes, remove Abdullah. Okay, yes. Thank you, Abdullah. Okay, now Abdullah, I removed it. Anyone else, please? Okay, خلاص. Thank you, guys. Now, let us go back because Abdullah, okay. Okay, yeah. Now, we return to question number 26. Which of the following is a statement of the principle of conservation of momentum? Yes, the momentum of an isolated system is constant. So this is next question, question number 27. It said the pole of mass. So we have here M. M equals 0.5 kilogram. Is thrown against the wall. We said when we explained this before, the rebound will be a positive. So we take this direction as this is the initial speed 12. So the initial speed is 12 and the final speed is 8. And this is the time. What do we need? We need the force. Which formula we use it? Yes, Zainab? Oh, the wrong person. Okay. Abdullah, please get out, please, Abdullah. Please, thank you. Okay, guys. Okay, here. Okay. Yes. Abdullah, please. Thank you, Abdullah. Get out. Thank you. Okay. So now here okay, this one. If you do not write, okay, here. Okay, remove. Yes, remove. Okay, here. This is removed. Yes, removed. If you don't write your name, I remove it. Sorry. Okay, now when you enter, please tell me your name, please. Okay. Thank you. Abian, Ahmed, okay, Asma, and Hafiz, okay. When you need to enter the meeting, just tell me your name, please. Okay, thank you. Yes, yes, thank you, thank you. Now, if you need to enter, yes. Okay, okay, thank you. Ahmed, do you need to get out, please, Ahmed? Also, if you want. Thank you. Now, okay, follow me, please. Question number 27. They said, what is the average force? Which formula we used it? The force multiplied by the time equals the change in momentum. So the force multiplied time equals mv minus mu. We said, what is the average force? The average force equals mv minus mu over t. We can take m common factor. So it's v minus u over t. Now we need to get the force. So the force equals, the mass already gave us 0.5. The final velocity is 8 minus u is in opposite. Then it's also negative 12. Over the time is 0.20. When we use the calculator, the answer becomes 100 Newton. So it's 100 Newton. So this is the question. Next question. Okay, yeah. State Newton's, okay, first law. Do you remember Newton's first law, please? State Newton's first law. And who can remind me about Newton's? Yes. Okay, Newton's first law. I will write here, but write the same as in the book. An object at rest remains at rest. Okay, and an object okay, in motion remains in motion. Okay, at constant speed. At constant speed, unless acted on by an unbalanced force. Okay, yes. Now, next question here. Okay. Okay. Yes. Yes, we can do this, Muaz. Every object continuous in its state of rest or with uniform velocity unless acted on by resultant force. Also, this is correct. Okay. Yes. Thank you. So I will use your chat here. Yes. Or you can take this. Okay. So thank you, Muaz. You can write also this. It's okay here. Okay. Every object okay, this one. Okay, here. You can write this. Okay. This correct, and also the other one is correct. Now, next question. Okay, next question. They said a box slides down a slope as shown in the figure. The angle is 20. The box has mass, so we have given here M equals 65 kilogram. The total resistive force are acting on the box constant when it slides down. So this is R. State the names and direction of other two forces. So just we have here one force, R. Then here we have the weight, W, and the normal contact force. So this is the normal contact force. Contact force. So the other two names are the weight acted downwards, and the normal contact force, and the normal contact force. Calculate the magnitude of the normal contact force. So we need R. Now, to calculate here the magnitude of the normal, we resolve the weight. Okay, here. Okay, now R, the normal contact force, equals W cosine. We said the box slides it down. So what is W? W here equals mg. M is the mass, 65 multiply 9.81. So it becomes 588.6 Newton. So this is the weight. Now, we need the normal contact force. When we resolve W, this angle is 20. So this W cosine 20. Then the normal contact force, sometimes denoted by M, it is W cosine 20. W is 588.6 multiply cosine 20, which is 553.1 Newton. This is the normal contact force. Yes? Yes. Okay, yeah. Now, next, calculate the acceleration of. The acceleration here comes from resultant force equals ma. So resultant force here, we have W sine 20. So W sine 20 minus here, okay, W sine 20. He said here, okay, calculate the normal, but here R acting on, it's okay. So here R is about here, okay, if it's R, it will be given here. So R, if R equals, for example, 100 Newton, sorry for that, then the formula is that W sine 20, W sine 20 minus 100 equals MA. M is given in the question. M here is 65. So it is 65. A. W already, we know that it's a 588.6 sine 20 minus 100 equals 65. From this, we can get A. Let us see which one we enter. Okay, yes. Okay, yes. Okay. The mass is 65, yes. The mass is 65, so W here, it is 6. Now, we can calculate the acceleration from this formula. So the acceleration is 588.6 sine 20, close the bracket, minus 100 equals, divided by 65, so the answer is 1.55. Then the acceleration is 1.56 meter per second square. Okay, now, okay, check here. Hussam, Nasser, and Hussam. Okay, yeah. Okay, guys. Now, next question. Any question, guys? Yes? Any question? Yeah. Question number 29. Okay. Question number 29, he said, okay. Yes. Oh, I check again what is the weight here. He said a box of, yes, I'll check here. The box is 65. I will check the 65. The weight is 65 multiply 9.81. So the answer is yes, 65. Sorry for that. So just I check this. Thank you. Yeah. So here the weight here. is 637.65 Newton. Yeah, thank you. And now we check this one here. The weight is that one here. So I cancel this. So the weight equals 637.65. Then I will check this answer here. Okay, thank you. Multiply by cosine 20. So the answer is 599.2 Newton. Thank you. Next. Okay, here, so the weight, it's not that. Yes. So here the weight is 637.65. Yes. So 637.65 multiply sine 20 minus 100 equals divided by 65. So it's 1.8. Thank you. Here it is here. The answer is 1.82 meter per second. Okay. Thank you. Yes, again, Nasser. He said the box slides down, the angle here. R is not given in the question, just we add this, okay? Yeah, R, yes, here. R equals 100 Newton, just we add this to this. Now, the weight here is mg. So the weight, Nasser, is mg. This is the weight. We resolve the weight, Nasser, into near to the angle is cosine, W cosine, and the away is sine. So the normal contact force is W cosine 20. Now, we need here to get the acceleration. He gave us in the questions R. He said R equals 100 Newton. Then we use the Newton's second law, resultant force equals ma. Then the forward force minus the backward force equals ma. So W sine 20 minus R, which is 100, equals ma. Then we can get the acceleration. Okay, Nasser? Okay. This question number 29. Yes, question? Yes. Okay, thank you. Now, question number 29, it said calculate the combined weight. Is that question easy for you? If you need from me to check it, tell me please. I give you time, about 5 minutes to solve that question, and then we return back after 5 minutes, okay? Okay, now, just I give you about 5 minutes, and then we return. Now we go to question number 29. In question number 29, he said, a man of mass 80 kilogram. So the mass of the man is 80 kilogram. A child 50 kilogram. So the total mass is the mass of the man and the child. So the mass is the mass of the man, which is 80, plus the mass of child, which is 50.5. So 80 plus 50, 80 plus 50.5 equals 130.5. So the total mass is 130.5 kilograms. This is the total mass. The two are attached to the cable. Then we have here the tension in the cable. So this is the tension in the cable. And this is the total weight. The total weight. Yes, question? Yes. Okay, yes. Now, the total weight here, we can get it. So the weight equals mg. So the weight equals mg. M is 130.5 multiply 9.81. So 130 multiply 9.81. So the answer is 1,000 280.21. In the exam, I ask you to write 2 decimal places. Newton. Okay, now left. Calculate the combined weight of the man. This is the combined. W equals mg. So it is 1280.21 Newton. This is the total. Next question. Calculate the tension when the initial acceleration, then it moves up with acceleration, 0.57 meter per second square. Now, what is the formula that we can use? Here, the formula is that the resultant force equals MA. So the tension minus the weight equals MA. We need the tension minus the weight, it's already 1280.21 equal the total mass, which is 130.5, multiply the acceleration 0.57. From this, we can get the tension. Follow me, please, and try to solve with me. So 1280, okay, plus 130.5 multiply 0.57. So the tension is 1354.59 Newton. Period of constant velocity. Constant velocity means the acceleration equals 0. So the tension equals the weight, which is 1280.21 Newton. Okay, next question. During the final deceleration, the tension. Now, here, this is the tension, and this is the weight. Calculate the deceleration. Of course, it moves up. So the tension minus the weight equals MA. The tension minus 1280.21 equals the total mass, which is 130, equals 0. No. We need deceleration. So now equals what here? So it's equals the mass, which is 130.5 multiply the acceleration. He gave us the tension. Then we replace the tension by its value. Then the value of that tension is 1240. We can get the deceleration. Then we write 1240 minus 1280.21 equal, of course it will be negative, divided by 130.5 equal. So the answer here is negative 0.3. So the acceleration is negative 0.3, and we need the deceleration. So the deceleration equals 0.3. The unit is meter per second square. Next question. Okay, let us see the next question, but I check if there is any other question. Yeah, Mr. Now, let us solve the question number 30. Read the question, please, and then we try to solve it together. I said an empty lift of mass is supported by a steel cable attached to the roof. Draw diagram to showing the two forces acting. The two forces here, of course, is the weight and the tension in the cable. So the weight equals mg. M is 1200 multiply 9.8. That is the free diagram. Now, next he said find the tension when the left is in a steady speed. So the tension equal the weight equals 1200 multiply 9.81. We calculate it. So it's 1200 multiply 9.81. So the answer is 11772 Newton. So this is when moving in a steady speed. A steady speed, it means that the acceleration is here. Now it moves up with acceleration. Then the tension minus W equals MA. We need what? The tension. So the tension minus 11772 equal the mass. Here the mass is given. It's 1,200. 1,200 multiply 1.5. We can get the tension from this. So this plus 1200 multiplied by 1.5 equals, so the tension is 13572 Newton. Ascending downwards, when it moves downwards, so the weight is more than the tension. The driving force is the weight, equals MA. The weight is 11772 minus the tension equals the mass, okay, 1,200, multiply the acceleration, which is, now we can get the tension, rearrange it. Then 11772 minus 1200 multiplied by 2. So the tension is 9372. 9372 Newton. Okay, question? Yes. 2 decimal places. Okay, the answer in the exam, I said that, and I will upload this lesson. It had the cover page. Read it more than one time. You will get this request that all the answers must be 2 decimal places. Now, next question. Define the momentum. The momentum is the mass multiplied by the velocity. So the mass of object, this is the momentum. The mass of object multiplied by its velocity. If you write MV, it will be wrong, by the way. I don't accept this, okay? And define the momentum in more details. This is enough. This is enough, okay? When I write something here, it means this is enough in the final. Now, we said a ball of mass 65. Yes, question? It is the mass of the object. This is the definition that I wrote, okay? Now, a ball of mass 65 gram hits a wall with velocity. It's okay? Now, just I give you the final answer because some questions are easy like this. The change in momentum, delta B, equals mv minus mu. But we rearrange, so we take the ribbon as a positive. Then the answer is 65 multiplied by 10 to the power negative 3 multiplied 5.2 minus 3.7. So the answer is 0.58 Newton second. The magnitude of average force, so the force equals the change in momentum over time, 0.58 over the time, I said 7.5 millisecond, 10 power negative 3. The answer is 77.1 Newton. Question? Okay. Yes, Maad? Yes. Like this, Maad? Or more? Okay. Okay, guys. Last. Now. Yes, Maad? Okay, thank you, Maad. Okay, now, next. Yeah. State the principle of momentum. Yes. Yes, Hajras? Yes, Hajras, what do you want? Yes. I wrote the definition. Khalas, Hajras, we don't need to repeat because of time. What is the conservation of momentum? Who can remind me? What is the conservation of momentum? Principle of conservation of momentum. Who can tell me? Yes. Do you remember this one? Yes. Who can write this? Okay. The conservation of momentum. Yes. Okay. Yeah. The conservation of momentum in isolated system, in isolated system, sum of momentum, the momentum is conserved. The momentum is conserved. This is the definition. Okay, yeah. The unit of momentum, not in notebook. Both are correct, my friend. The unit of momentum is Newton second or kilogram meter per second. Both are correct, my friend. It's okay? Or kilogram meter per second. Or it's okay? Both are correct. Newton second or this. Both are correct. Okay? Now, next question. Okay, here. It's okay, just I give you the quick yes question. Okay, now let us we go to this question. The total initial momentum, which is M1 U1 plus M2 U2 equals 0.4 multiply 0.65 plus 0.6 multiply 0.45. So the total is 0.53 kilogram meter per second. Next question. He said find the velocity. We write M1 U1 plus M2 U2 equals M1 V1 plus M2 V2. So before it is 0.53 equals 0.4 multiply 0.41 plus 0.6 V. From this, V equal 0.61 meter per second. Next question. He said the total initial kinetic energy. Initial, it's okay. So it's a half M1 U1 squared plus half M2 U2 squared equals half multiply 0.4 multiply 0.65 squared plus half multiply 0.6 multiply 0.45 all squared equals 0.15 joule. Explain how you would check whether the collision is elastic. Check the total. So we have to check the total, okay, final kinetic energy equals the total initial kinetic energy. So this is how to explain, is it elastic or non-elastic? Of course, in case of elastic, the total initial kinetic energy equals the total final kinetic energy. Yes, question? Okay, inshallah. Okay, now, next question, question number 33. We said a bullet of mass 10 gram is fired at 400 meters per second from a rifle of mass. What is the recoil velocity? Here we write here the total momentum before, so the sum of momentum before equals the sum of momentum after. Then 0 before to 0 equals M1 V1 plus M2 V2. 0 equals 0.01. I converted to kilogram, multiply by 400 plus 4 multiply V. From this, V equals -1 meter per second. So the recoil velocity is 1 meter per second. Now, next question. He said the bullet is fired into a block of wood of mass 390. The same, we write before, okay, equals after. Of course, we talk about momentum. Before, it's m1 u1 plus m2 u2 equals after. Now they move as one object, m1 plus m2 multiplied. So 0.01 multiplied by 4 plus 0 equals 0.01 plus 0.39 multiplied. From this, V equals 10 meter per second. So in the same direction as well. In the same direction as put. Okay, question? Yes. Okay, Maad. Thank you, Maad. Yes. Now, next question. Question number 34. He said, find the change in momentum. So the change in momentum denoted by delta B, which is the final momentum minus the initial momentum. Okay, Maad? Yes. Now, it is 0.06 multiply 31 minus 0.6 multiply 0. The answer is 1.86. The unit is kilogram meter per second. Next question. The average force, the force multiplied by the time equals the change in momentum. So the force equals the change in momentum over the time. The change in momentum is 1.86 over here. The time here is, said that here, the time of contact is 25 milliseconds. So this is the time. Milli, we multiply by 10 power negative 3. So divided by 25, multiply 10 power negative 3. So the average force is 74.4 Newton. Next question. Yes, question. Okay. Excuse me, please, guys. If you have important question, just write. If you don't have, please don't write. So don't stop because we don't have time to read what do you write. Thank you. Now, question number 35 here. We solved this and the answer is at position Q because clockwise moment equals anti-clockwise moment. Question number 6, he said, an object made from two equal masses joined by light rod falls with uniform speed through air. The rod remains horizontal. Which statement about the equilibrium of the system is correct? So is correct here, this, okay? But if I write incorrect, so try to think of this. If it is not correct or wrong, so think of that question. If I write here, not correct. Next question. Question number 37. He said, which row describes the resultant force here? The resultant force here not equal 0. And also the torque not equal 0 because it will be rotated. So the correct answer is in. Now, this question here, he said, a uniform meter rule of mass 100. Uniform, it means act at the middle. Then here we have at the middle, we have here 100 gram, okay? Of course, this is, we change it to kilogram and we can write the word, 40 centimeters. At the middle, it means this distance is just 10 because it's at the middle, 10 centimeters. Because the total length is 100. And the strength, so we have here the tension. This is the tension, okay? Now, the tension here, okay, equals, okay, 20. But here we have to convert it to, but just we write the tension equals 20. Okay? Now, he said at which mark on the rule must 50 gram mass is so that it is balanced. Let it is here. So this is 50 gram. let its add distance from the pivot is x. Now, the clockwise equals the anti-clockwise. Then we write here, 50 multiplied by x, the distance from the pivot, plus, we have another one. So 50, okay, here, plus 100 multiplied by 10, the distance from the pivot, equal the tension, it's a 20, multiply the distance, which is, the distance is 60, because at 40, 40 to 100 is 60. From this, we can get x. Let us solve this. Then 20 multiplied by 60 minus 100 multiplied by 10 equals divided by 50. So x equal 4. But actually, we calculate the distance from the ruler. So x equals 4. And from support to the beginning is 40. Then it mark at 44. 40 plus 4 equals 44. So at 44 centimeters. Okay. Question? Yes, why not? 20. I said again. The clockwise moment equals the anti-clockwise. Here, because all the weight in gram, we don't convert to 2 kilogram. Also, I did not multiply by 9.81. Of course, the force equals mg, but because it is multiple choice question, so just we need x. So the mass, okay, here, the weight acted at the middle. The middle, it's at 50 from the beginning, okay? At the middle, it says 50. So, and the pivot is at 40. 40 from 50 equals 10. So the distance from the pivot is 10. Let the mass 50 gram at x from the pivot. So this distance is x, okay? We need this x, okay? Now 50 multiply x, this is the clockwise, plus 100 multiply 10, this is clockwise, equals anti-clockwise. The tension has distance 60 from the pivot. From this, we calculate x. X equal 4. But we need the distance from the beginning. From the pivot is 40. From 0 to the pivot at 40. And x is 4. So the market at 44. So this is the answer. Next question. Question number 39. Of course, we solved this. What is the weight? It is direct question. Clockwise equals anti-clockwise, so the answer is 25. Now, also, this one, it is the work done of 9 dogs. We need the work done by 1. So the work done equals the power multiplied by the time. Then it is 800 multiply 1.5 multiply 360 multiply by 60. Then the work done equals 2.59 multiplied by 10 to the power 7 joules. This is the total work done. But we need for each dog, from each one we divide by 9. Okay, so it's 2.88 multiplied by 10 to the power 6 joules. So the answer is that one. This is each one. Okay, we divide because this is for the total. Yes? 39, just the clockwise equals anti-clockwise. Yeah. Diagram shows uniform BQ. The length is 3. Acted at the middle. Yeah. The weight is 50 Newton. At the middle, it means 1.5 meter. And this 1.5, so the distance from the pivot is just 0.5. And then we write the clockwise equals anti-clockwise. Question number 41. Okay, just here we need the kinetic energy. It's a half mv squared. So it's a half multiply 1400 multiply by 30 squared. So the correct answer is that one, part C. Now, Here, the gain in potential, we calculate the potential energy
مستر
and we calculate the kinetic energy and we get the sum. So the total is the potential energy plus kinetic energy. So the answer is yes, Osama. Yes, ask me, Martin. Yes.
are you sure question 41 the answer 630
Yes.
kg?
Yeah, because
Because
it
in
will
the
be joule.
calculator it turned out 21,000.
I will explain. Okay, half multiplied by 1,400 multiplied by 30 squared equals. So the answer here, Osama, is
Yeah.
4 zeros. 1, 2, 3, 4. Divide by
Yes.
1,000 to be kilojoule, divided by 1,000. So it is this answer, okay? It is 630 kilojoule. No.
Okay.
Next question. Define the torque of couple. It is the product of one forces and the perpendicular distance between the forces. So the product of one force and the perpendicular distance between the forces. Next question, it said calculate the torque of the root. The torque equals one force multiply the perpendicular distance, which is 12 Newton meters. Discuss briefly whether the root in equilibrium. No, there is a resultant torque and is not in equilibrium. So there is a resultant torque and is not in equilibrium. Next question. They said explain what it meant by center of gravity. Is the point, okay, where the weight of an object may be considered to act. Define the moment of force. It is the product of force and perpendicular distance to the pivot. Distance to the pivot. Now, okay, he said here, state the two conditions necessary for the equilibrium. Please let the questions at the end, okay? Okay, please, because just to reduce the time, let the question at the end of the lesson. I will reply, I will answer all your questions, but just to finish on time. State the two conditions here. Resultant force is 0. طبعا, we can say in any direction, in any direction. The second, resultant moment is 0 about any pivot, about any point. Okay. Next, we need to calculate here the weight. Okay, the weight of them. Just we need to get the distances. Okay, we calculate. We solved it in the class, so we need to get the weight. So I give you the value directly because just the time. So the weight multiply 0.2 equals 80 multiply 0.5 plus 70 multiply 1.3. From this, the weight will be 655 newton. Now what we do, no change, just we move the pivot to the left. Move the pivot to left. And this gives greater clockwise. Now, question number 45. Okay, yeah. Okay. Calculate here the gravitational potential energy when a person of 70 kilogram. So the potential energy equals mg delta H equals 70 multiply 9.81 multiply 19. The answer is 1.3 times 10 to the power 4 joule. Part B, we need, okay, that raised 490 grams to 130. Also, delta GE, gravitational potential energy, it is 0.94. We have to convert it to kilogram. Multiply 9.81, multiply by 1.3. The answer is 11.99 joule, or approximately 12. Next question. State the principle of conservation of energy. Energy cannot be created. I will write for you this. Okay. Energy, okay, cannot be created or destroyed. Okay, it can be converted from one form to another. So this is the conservation of energy. Next question. Yeah. In that question, just we draw a triangle. This triangle represents here this relation. It's right angle triangle. And this is 5. And this is 40 meters. And this is the height. So sine 5 equals the opposite over hypotenuse. Then the height equals 40 multiply sine 5. Now, he said, calculate the loss in gravitational potential energy. So delta BE, potential energy, equals negative, because negative means loss. Negative mgh. So it's negative 90 multiply 9.81 multiply by 3.49, the height, the vertical height here. H is this one. It's okay. H equals 40 multiply, which is 3.49 meter. Now, so the answer of this one is negative 3.08 multiplied by 10 to the power 3 joule. So the loss in potential energy is 3.08 multiplied 10 power 3. Second part, we need the increase in kinetic energy. Kinetic energy equals half mv squared. We have the speed, we have the mass, so we can get it direct. Half multiply 90 multiply 12 squared equals of 6.48 multiply 10 to the power 3. So this is the increase in kinetic energy. Next question. Define the density. Okay, yeah. Density is the mass density of substance, density of a substance, okay, is its mass per unit volume. The mass of the cylinder, of course, I will give you in the formula sheet the volume of the cylinder. Here, the mass equals 200 grams. We convert to 2 kilograms. And here, the height of the cylinder, he gave us the height. It said 6 centimeters. Okay, and the diameter, this is all the diameter here, the diameter equals 2 centimeter, so the radius equals 1 centimeter, we convert to meter, all. Then the height in meter, 0.06 meter, and the radius is 0.01 meter. The volume is by r squared h, the volume of the cylinder. So it's by bracket 0.01 squared multiplied by h, which is 0.06. So the answer is 1.88 multiplied by 10 to the power negative 5 meter. The density, denoted by rho, equal the mass over the volume. The mass is 0.2 over the volume, 1.88 times the 10 power negative 5. The answer is 1.06 multiplied 10 to the power 4. The unit is kilogram per meter. So this is the answer. Next question. Define the pressure. Pressure is the force per unit area. Force per unit area. Now, next, we need here the sphere of radius immersed in the liquid of density. Calculate the upthrust. Now, the upthrust or bearing force equals rho GV. Here the radius is 4.5 centimeter. We convert to meters, so 4.5 times the 10 power negative 2 to be in meter. Okay, so we can get here, okay, here the density, he gave us the density, rho equals 800. Then it's 800 multiply 9.81. The volume of sphere is 4/3 by r cubed. R is 4.5 multiply 10 power negative 2 all cubed. We calculate this, it will be 3 Newton. So this is the upthrust. Next question, define the power. The power is the rate of converting energy. The rate of converting energy. So this is the power. Next question, he said a small electric motor is used to lift 1.5 Newton through a vertical distance. Calculate the useful power. The power equals the energy over time. The energy equals the force multiplied distance. The force is the weight. Then it becomes 1.5 multiplied the vertical height 1.2 over the time 2.7. The answer is 2/3 and the unit is watt. Next question. Calculate the amount of energy converted. Remember, we can use this triangle here. The energy, the power, and this is the time. So the energy equals the power multiply time. Here we have the power in kilowatt. We convert to watt multiply by 1000, 10 power 3. And the time here is at 3 minutes. So we convert to second multiplied by 60. Then the answer is 4.32 multiply 10 to the power 5. The unit is. Okay, now this is the revision sheet. Now, if you have any question, you can tell me. Yes, question. Yes. Which one you don't understand? Negative because it's lose of energy. Because when we go down, the potential energy loses. Okay, but when the kinetic energy increases if we speed up. Yes. Question number 48. It's okay. Turn back to question number 48. Yes. Here we find the volume of a sphere 4/3 by r cubed. This is the radius, and this is the Bayesian force. It will be in the formula sheet. Can you see here? So it's rho GH, okay, Bayesian force. So now this is the formula sheet that you will see in the exam. It contains everything that you need. Here's the volume of cube, the volume of a sphere, 4/3 by r cube, but just here, okay, 4/3 by r cube. and the volume of cylinder is by r squared. Yes, question? Yes,
Master,
Mu'ad? Yes, yes, Osama.
uh, can we, in the exam, when we write the answer, we write a different answer, but it must be the same meaning, the correct meaning.
Of course, yeah. Here, but read the cover page. Be careful again. The time is 3 hours. I advise you guys to start the exam with the extended question. Do not start the exam with multiple choice. I advise all the students, also in grade 12, do not start the exam with the MCQ, because to get time to think, because in MCQ, I change many words. And also, I advise you, again, I repeat more than one time, do not memorize the answer of MCQ, because completely I changed them. So please try to think of each question in MCQ. In the extended, do not memorize the final answer of any question, because I changed it, okay, the number. Here, the exam has 23 pages. Okay, do not use the corrector. Use the scientific calculator FX95 is only the allowed. Also, the acceleration of free fall is 9.81 meter per second squared. Okay, use the pencil to solve MCQ. Again, I repeat, do not use the pen in MCQ. Okay, guys, I hope you understand, okay, this lesson. Any other question? Yes? Thank you, Osama. Thank you very much indeed. It's okay? Ready, guys? Okay, thank you. Salam alaikum. Yes, any other question? Can you explain again 44? Okay, 44 again. Okay, 44. Yes. Okay, 40, question number 44. Yes. Question 44, I solved it in the class. I said again, just you have to get the distance from the pivot. So this is the trick of this question. So you need to get the distance from the pivot. For example, here, this is 0.5 and the total and 0.3. So 0.5 minus 0.3, it is 0. And this is 2 meters. And this is at the middle, so it's 1 meter. So this distance here is 0.5 meter. And this is 0.2. And the total is 1 meter. So this distance is 0.8. Then the total from 70 to the pivot is 0.5 plus 0.8 equals 1.3. Okay, just we need to get the distance from the pivot. Yes, question? Yes. Yeah. 48? Yes, this is 48. Yeah, 48. It's okay. Now, question number 48 again. Yeah. Okay, here just we find the volume. The volume of a sphere is 4/3 by r cubed. This is r. This is the volume of sphere that we calculate. This is the volume of sphere. Okay, and rho is the density of the liquid, and the g is the acceleration of gravity. Just we do substitution and we multiply by using the calculator. Okay, guys, now we took approximately 2 hours for revision. I hope tomorrow the exam will be easy for you. Okay, yes, last question. Thank you very much, Muhammad. Thank you for all. Okay, yeah, salam alaikum.